Hi, this is David Harper, Bionic Turtle, with an introduction to CreditMetrics, which is a credit risk portfolio model published in 1997 by J.P. Morgan for FRM candidates. CreditMetrics is one of the 4 or 5 credit risk portfolio models that we look at. This is a copy of the framework which illustrates the 4 building blocks that are part of the CreditMetrics framework: 1, 2, 3, and 4. Although essentially we can think of the CreditMetrics approach as being about the first 2 essential building blocks, and 3 and 4 support the second building block. The first building block explains why CreditMetrics is, as Jorian calls, a bottom-up approach. That's because it starts with individual bonds, or for that matter, it can handle many different types of credit exposures. But there is an estimation at the individual facility or bond level of the value at risk due to credit, or the credit VAR. That's why we call it a bottom-up approach. And in doing this, which I'll show in the spreadsheet next, the CreditMetrics approach uses credit ratings and migration likelihoods to compute the standard deviation of value due to credit quality changes for a single exposure. This is the first key building block, the calculation of the standard deviation of value for the individual bond or exposure, and then using these third and fourth building blocks, including, importantly, the correlations between exposure. The CreditMetrics framework develops a portfolio value due to credit risk. So now I'll switch over to the spreadsheet and show you the example of this first all-important step in the CreditMetrics framework. Here's the spreadsheet that illustrates that first building block in CreditMetrics. I'm using numbers from the original CreditMetrics technical document, and I will upload this spreadsheet to the member page for those who'd like to take a closer look. We'll see immediately that within the first building block there are 4 sub-steps. However, let's keep in mind that the essence of this approach is to combine 2 elements: a credit rating transition matrix and forward curves, or forward zero curves, to price the exposures. So I'll show you what I mean. Our example computes the credit value at risk for a triple B rated bond. Our first step is to specify the 1-year transition matrix that's shown here. The 1-year transition matrix gives us, if we start at a row over here on the left, so we're going to start at a triple B rated bond at the beginning of the year, what we have in the row are the probabilities, the marginal or unconditional probabilities, that that bond will migrate to another credit rating category before the end of the 1-year period. So the time horizon is important on this. This could be a 2-year, 5-year, 10-year. This is just a 1 year. And therefore, for that short period, the highest probabilities will be in the diagonals, because it's most likely that a double A will remain a double A. And in our case, a triple B has an almost 87% chance of remaining a triple B, at least during the 1-year period. Notice, but also, here there is a 5.3% chance that if we start at triple B, there will be a downgrade or a downward migration to the double B. That's the meaning of migration or transition in the matrix. Similarly, we have an almost 6% chance that if we start at a triple B, we can migrate to a single A. And so, especially for FRM candidates, I like to remind that if we look at this row here, this is really an empirical distribution, to use Guardi's terminology. What we have here are the mutually exclusive probabilities, a histogram, if you will, of outcomes conditional on starting the year with a triple B rating. And if we add them all up, because it's a distribution, that way it's a probability distribution, they sum to 100%, or 1.0. So that's the first step, the specification of this 1-year transition matrix. Remember, we're going to compute the credit VAR for a triple B rated bond. We'll move to the third step, because the second step is to specify the horizon. We keep it simple here and assume a 1-year horizon. So we go right to the third step, which is the specification of the forward curve. So if we have spot rate curves, we know that we can extract forward rates out of that, and what we get are for each rating category. So that means in this case we have 7 rating categories. We have 1 year forward, the 1 year forward zero curve, or in other words, if we go 1 year forward, what's the 1 year spot rate? If we go 1 year forward, what's the 2 year spot rate? If we go 1 year forward, what's the 3 year spot rate, and so on. And I've got that graphically depicted here. 7 lines, 1 for each credit rating category, and then we have the forward curve. So for example, as you'd expect, the lowest credit rating quality, or CCC, has the highest values here, and here we have at about 15% the 1 year forward, 1 year zero curve, meaning in 1 year forward we are predicting that the 1 year spot rate will be 15%, and in 1 year forward the 2 year spot rate at that point in time in the future will be about 15% as well. So here's the forward curve, and that's the second key part of this, remember, in addition to the migration matrix, because we use the forward curve to price the bond at the end of the period 1 year in the future. So if we go down here to the fourth step, and now we describe our bond a bit. Remember, it starts the period rated BBB. We assume it has a face value of $100 with a 6% coupon. That means the cash flows are as follows. A 5-year maturity. So we're going to have a $6 coupon, a $6 coupon, a coupon, a coupon, the fifth and final coupon plus the return of the principal. So that's our cash flow characterized by this BBB rated bond. Then what the CreditMetrics does is it goes forward 1 year in time, and remember, we start the period at BBB, but at the end of the year we could theoretically be in any of these categories. Most likely will remain BBB, but we could migrate up or migrate down. And what this approach does is it prices this bond at the end of the year for each of the possible outcomes. So here we have the BBB, the most likely, and then we take the cash flows, those are right here, and we discount them using the forward rates above here. So the BBB 1 year forward, there's a $6 coupon, that doesn't get discounted. Then there's another coupon that 1 year forward gets discounted at the 1 year forward zero rate, and each cash flow for that bond gets discounted, and if we sum those, we end up with the present value of the bond, but it's 1 year forward, and so we've priced it using the forward curve. And if we go up here, for example, to the AAA, remember that forward curve for the AAA is right here. It's the one here at the bottom with the highest credit quality, and so it's going to have the lowest discount rates and produce the highest present value or sum of present value of the cash flows. And so what we end up here in this final column is the estimated price of the bond in 1 year depending on which rating category the bond ends up with. Probably here, but could end up here, could migrate here to single A where the quality is higher and the discount rates are lower, and therefore the present value of the cash flows is higher. And this gives us really the essence of the CreditMetrics approach, which is a set of price outcomes on this bond in the future, and also we input an estimate for in a case of default using a recovery rate. So here we've got the prices, and then moving over to the right we've got the probability of each of those outcomes. This is just that transposed row from the credit migration matrix, where here remaining BBB is the most likely. Now that we have the distribution of prices of the bonds and their probabilities. I won't go into the detail here because this is all just the calculation of the standard deviation given this distribution of price values. So here we've calculated the credit value at risk for this BBB rated bond based on that migration matrix and the forward curve. So this is David Harper, the Bionic Turtle. I hope this was helpful. Thanks for your time.